Two numbers.
Okay, combine and count, right? Yeah, so so we can combine, just throw stuff together. We actually have to get the sum, so that's the count. So addition is to combine and count. All right, so we got a model for addition. What did we use last class, and what do you think we're going to use today for a model for decimals? Yeah, base 10 blocks. So for now, a decimal are base 10 blocks. So start off with a simple one. Suppose we wanted to do 3/10, add that to 1 2/10. Let's see how good I do without speaking math slang today. So if you could, whip out your blocks and make a model for that.
We're using this one as a whole.
Yes, let's use the big one as a whole. Uh-oh, what happened? I can only use it for 5 minutes a day? Oh. Sign up for free. Fine.
Don't fall for it if it asks for a credit card.
Yeah, hopefully it doesn't get that far. Let's see, we use that email. Yes, I'm 18 years of older. Create my free account. Sorry, I didn't realize this app had that in it. I'll find another one that doesn't require you to sign in. I swear I had one here. Almost done. Check your email. The only one I gave. Pattern blocks, hex, color fraction strips. What's this one? That'll work. Okay. So there is 1 and let's see. No, I have 1.2. All right, so there's 0.3. Oh, I did it. I said slang. And here is 1 2/10. And so then we just need to combine and put them together. And not much changes, but I get to give it a whole new name. And the new name is what? 1 5/10. Beautiful. Right, so combine and count. Pretty straightforward there. Let's do another one. How about 8/10 and 7/10? You got your blocks. Build it. Let's see. Just trash everything. Select. Ooh, interesting. Yes, sir. 1 2 3 4 5 6 7. 1 2 3 4 5 6 7 8. All right. Does it let me join them, I wonder? So can I take 2 over here and say, trade me in? Break pieces, join pieces. Oh, that's so cool. And it looks like my answer is 1 5/10. You guys get a similar thing? Did everyone build a flat with their longs? Cool. All right. So, can I do all that? Ooh, that's interesting. I didn't want that to happen. So now let's draw a picture to go with this. So let's bring out our best bit of art stuff. So I'm just gonna do my easy way of drawing it. 1, 2, 3, 4, 5. And I talked about this a little bit last term. Visually, people can see groups of up to 5 pretty easy with just a quick flash. But after that, we lose track and we have to start counting. So usually when I'm playing with these toys, if I have more than 5, I put a group of 5 together and then have another group next to it. And there's a popular kind of card game that's used in schools called 10 frames that do that. Anybody remember what 10 frames look like from last term? You don't remember, really? So just a reminder, 10 frames are kind of fun, and you can usually play with decimals too. 10 frame is a rectangular card, and that rectangle is split in half, and then you have 5 cells in each column. So to demonstrate 8, a 10 frame card would look like that. So a 10 frame card is set up to always be able to have a group of 5, but there's also groups of 10 inherent in that. So there's just a bunch of cards that look like that. I think as a kid, really easy for kids to work with. What's that?
I did some observations in kindergarten.
Do you remember seeing 10 frames in there? Yeah, and playing cards are nice because playing cards have, 8 hearts for an 8 and so on. However, they're in kind of a weird pattern. It's a symmetric pattern, which is nice, but kids still have to count them. And once they get used to the groups of 5, visually they get this instant recognition of it, which is a good thing because it's a mental pattern that can help them later. So anyway, I try to use that practice a lot. So I want to combine that with a group of 7. So then I put them together. And so now I have my 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which I'll just bound like that. And then I'll have my 1, 2, 3, 4, 5. So here's my 1 5/10 answer. So I combine it and count. So it's not too much different than we did this with whole numbers. So this looks really just like 8 plus 7 with these blocks here. Except the knowing which piece is a whole allows us to put it in the context of a decimal. And there's really not much more exciting stuff we can do besides that. Let's see. Is there something I should add to this to make it a little bit more clear?
Something to say that you traded to.
Yeah, I should make a note of that. Here, I did a trade of 10 tenths for 1 whole. And do you remember why it's important to put that in there?
Because if you don't, it's not obvious that that's what you did.
That's part of it, yeah. If I know it's not obvious, that's what I did. But there's another reason. So write down how you would solve this problem without any toys. Someone says, hey, add 8 tenths to 7 tenths. What would you do? Would you write it like this, maybe?
Because you have to trade it no matter what when you're doing
8 and 7 is 15, the decimal comes down, right? So when we do it that way, we're just kind of getting used to that pattern of what we call carrying, where we bring a digit into the next place over. And we called it carrying, but we're really just trading, is what we're really doing here. Maybe one more example to kind of emphasize that. All right, so one more and then we'll move on to subtraction. Let's take 1.6 and add that to 1.5. So do two different things here. Whip out your toys and do it, and then draw a picture of it. So just a note on this one right here. So normally I would write it as 1.6 plus 1.5. And 5 and 6 is what? 11? It's 11 tenths, and I write it like that, right? No. What do I do wrong? What's that?
Carry one.
I forgot to carry the 1. Which one do I carry? That one? No, backwards. Which one do I carry?
The tens one.
Oh.
Tens?
So like in the tens place, so the one.
No, we don't have tens.
You have
place
to
here.
add 6 and 5 and then take the tens, the number in the tens place from there.
Say it again.
You have to add the 6 and the 5 and then take the number in the tens place and carry it on top of the
I don't have any
number
tens
that's in the
here.
ones.
I
The
don't have
ones
any.
in the ones place, not in the tens place.
Ones.
So I'm taking the 6 tenths and the 5 tenths,
Yes.
which gives me 10 tenths, which is really one whole. Well, and that's why I carry.
Yes.
Okay, and that's this step of oops, wrong arrow. And so just to get used to, remind them that, hey, 6 tenths and 5 tenths, I can group some of that to get one whole. So that's why we carry that one whole up, and we have one extra tenth that just hangs around. So carrying is, again, a word that's kind of discouraged in using that when you talk to kids about it. It's what we're doing is we're trading in. What are we trading? We're trading 10 tenths for one whole. And that's why it goes up there. And now I have 3 wholes in 1/10. So trade 10 tenths for one whole. So that's why I think it's worth mentioning there, because it's like why we do that carry. And I think you'll see if you do teach a grade level that does this, you won't see the word carry very much at all. It's all about trading in, just to get kids to focus on the idea of place value, because that's the more important idea. All right, next, subtraction. Oh, before subtraction, that model leads to an algorithm. So this is my algorithm right here. This is my algorithm right here. What's the important part of that algorithm?
The trading.
Not the trading. That's kind of just a side thing. There's something that's more important going on.
Combining count.
Almost. Let's do one more example. What's that?
The decimal?
What about the decimal?
I don't know.
Bringing it down to the answer.
Okay, hold on. Right here?
Where you put it.
Where you put it, Emily?
I said the placement of the decimal.
The placement of the decimal? Yeah, you gotta line up the decimals in order for this to work. Why?
Otherwise you're gonna have some crazy number, is that right?
Okay, you're gonna have some crazy number that's not right. That's true. Why would you get a crazy number that's not right?
Well, because if you added like 7/10 to 8/100 by accidentally moving
Yeah.
things over, you're gonna end up with a
Yeah, what, is that 15 of what? 7/10 and 8/100. That's 15 things, but it's not any meaningful answer. Yeah, so let's just do one more to double check that. Let's take, this was easy, an extra one. How about 1.1 plus 0.23?
Can't you multiply with decimals and do lattice also, and don't you follow a line down or something? It shows
You can use a lattice for decimals. Finding the decimal place is not obvious, but we'll talk about that. I mean, it'll be obvious to us, but it won't be obvious to kids how to find the decimal spot. So draw a picture of this first. Or whip out your toys, or both. I'm going to whip out my toys here.
What was it, 0.
1.1 plus 0.23.
For 1 and 1/10 thing.
Ah, I did slang. You got me, yes. 1 1/10 and 25/100ths.
Or 2300s or
3, yes, 2300ths. Got me all flustered now. Okay, so 1 and 1/10. And combine that with 2/10. 1, 2, 4, 5.
23.
3. Why do I keep doing 5?
It's
That is
easy.
very bizarre. Can I? Oh, I gotta hit trash. Trash. Okay, I got it. So with the pieces, it's almost trivial, right? There's one whole. There's 3/10, and there's 3/100. A lot of kids are going to accidentally go like this and just line things up using the right side of the numbers, right? But we know that's not a good thing. We need to have decimals line up. Because ultimately decimals are fractions, and you can only have fractions with common denominators, and lining up the decimal point lines up your denominators. Tens get added to tens, hundreds get added to hundreds. And we get 3 hundredths, 3 tenths, and 1 whole. So the picture is super obvious, but it's not as obvious once we move to the algorithm part. So our algorithm is just line up the decimal point, add like usual. Emily, question?
Is it a good idea to have them put a 0? Like, that's what I was going to.
Oh, 1.10 to make,
Or
I'm torn about that one right there.
bad.
It's good.
Is it? If
I don't
we
have a good argument
understand-
today that it's necessary, but I can see where somebody might. What's that?
Is it only good if they like understand reduction of fractions, so they see that's 10 100ths, but
The
it's
10
also
100ths or it's
1/10.
1/10. And that's a cool thing to do. I mean, you're gonna need that sometimes. Yeah.
Is that what?
Yeah, so I guess I would lean toward putting the 0 in there, especially with a lot of these kids are messy at this age. So we could say fill in zeros where digits aren't present.
Because
Yeah,
if there
that's
was
a good idea.
like
I would-
1.03,
You guys convinced me.
because there would be a 0 there if it was like 3 100ths.
If we're missing a 10th, we would put a 0 in, definitely.
So it would be this kind of
Yeah,
the same.
same idea.
Okay.
Yeah, I like that idea. All right, so for our algorithm, it's simply line up the decimals. And by that I mean decimal points. Place decimal points in same position below. Then add as if they're whole numbers.
You got a little excited on your feet there.
I did, yes. What happened there? That's supposed to be an E. Yeah, so as long as they're good with carrying, as long as we line up the decimal points in the numbers, we know where to put the decimal point in the answer, and we add as if they're numbers. Okay, subtraction. What's one of our main models that we use for fractions? What's that?
You said fractions?
Yeah, when we work with fractions, what was our main model for what subtraction meant with fractions?
Area?
That was multiplication. Area was multiplication. What's that?
Takeaway?
Takeaway is 1. There was one I thought was better than takeaway.
Here's that.
That would be division.
Division.
No, multiplication, sorry. We're getting there. Comparison.
Oh.
And
You
the
always
reason I
say-
like comparison is comparison forces you to draw both of them, whereas takeaway, we just draw the first one and try to pull the second one out. So with the comparison, we're trying to say, how are they alike? And how are they different? The answer with comparison is how are they different? because remember, another word for subtraction is difference. It's the difference between 4 and 7. You would say, well, it's 3. They're 3 apart. So if we have 7/10 and we want to compare that to 4/10, so I'm going to draw them sideways. There's my 7/10. There's my 4/10. They're alike in that they both have 4/10 in common. But they're different in that 0.7 is 3/10 more. So that difference is the answer. And it was a little harder to do takeaway with fractions. It's a little easier to do takeaway with decimals because they're pretty similar and they're easier to break apart. We don't have to worry about a different denominator as much. So let's do another one of these. So this time what I want you to do is get next to a partner, and we'll do 2 different problems. I want you to demonstrate the subtraction problem with the toys to your partner. And when you guys do that, I'm going to talk to myself like I have a partner up here in the video. So let's take the problem I want you to try first will be 2 and 3/10. Take away 0.6. I did slowly. 6/10. And you can use the takeaway model if you want. That works great here too. Or you could use comparison. You decide. So one of you is going to decide who's going to be the demonstrator first. And then the next round, do the problem 2.4. Slang. 2 and 4/10. Take away 7/10.
So we're just solving.
You just solve, so first one person will show the other person how to do the black problem with the base 10 blocks, and then you'll switch. The other person will show how to do the blue problem with base 10 blocks.
Sorry.
All right, for my video audience.
Swap things up. And I don't have a, so I'm just gonna pretend. Okay.
No, don't pretend, actually use the blocks. Come on.
Okay.
You got tons of blocks here. 2.3, okay, so 2 and 3/10.
So now we can take 6 away from this one. 6. 1. So then I left it, and then
All right, and then I need 6/10. Fun digital toys. 6/10. 1, 2, 3, 4, 5, 6. And let's change their colors. Okay, so here's my 6/10, and I'm comparing that to 2 and 3/10. Problem is they're not directly comparable.
So I gotta trade in one of these guys here. So let's break it up into pieces. And then I can do my comparison. So let's see. Take these guys and line them up. Regroup these suckers a little bit. All right, got 5 there. So then maybe what? I'll stick these on top, see where they line up.
Oh.
So now I can see how they are different.
Oh, maybe it
So
was
I
too
got
many.
1 and 1, 2, 3, 4, 5, 6, 7 tenths.
Oh, hold on. I think I
Screenshot
just-
that, draw on it.
I did. No, I don't know where I got these numbers. These are not even up there.
You did a whole different set of numbers. That's okay. I don't care which numbers you do as long as you do something.
Okay.
All right, so what do we got here? We started off with
I mean, it worked for whatever problem we got.
As long as it works.
2 and 3 tenths.
Yeah.
And we compared that to 6 tenths. And then that leaves,
Do we have a potty break soon?
sure, potty break anytime.
Well, I'm gonna do it now.
1, 2, 3, 4, 5, 6, 7. 1 and 7 tenths. And so, ooh, whoa, what did I do there? I wrote numbers just like I thought them. There we go, 1 and 7 tenths. So an important part here was this, that I had to trade 1 whole for 10 tenths. Or in other words, I took 2 and 3 tenths and rewrote it as 1 and 13 tenths. So that way I could compare to the 6 tenths. That was fun and exciting.
Decimals are easier.
Decimals are way easier, no doubt, in most cases. The problem is dealing with things like 1/3 and rounding, scientific notation, and significant figures, which we'll talk about later.
Figures was the worst thing I think I've ever done in science.
Yeah, significant figures take some getting used to, but once you get the idea, it's not as much of a problem. And we will play with that at the end of this
I don't think
chapter.
I ever got the hang of that.
Yeah. We'll talk significant figures,
Which was,
and I'll try to explain why they make sense. And it didn't make sense to me until I had to teach it. Like I could do it, I knew when they wanted and what it should be, and then I had to teach it, and it was like, oh, okay. Taylor, you gonna say something?
Yeah, when we were going over it, I was also going over it in chemistry, so I was getting double this.
Oh, yeah, that helps. We are gonna do partners again, yes, with the toys, yeah, because we're gonna make multiplication arrays next. So I'm gonna pause this video and make a new one. Now's a good time to stop.